Hi, I'll try to make this one short. What you see here on the screen is the location data model. It's a model containing all entities that capture location information of some kind. For example, addresses, buildings, routes, and that sort of things. The model is based on SIM, and but I will not go into much detail here about SIM. For more information about that and why we have chosen to use SIM as a basic for designing our data models, there's another video that you can look at where I try to give an overview of the SIM standard and why we use that. You can see it here. It's called Why and How SIM is Used to Model a Fiber Network. This is very general and overview-ish, but hopefully will give you some kind of idea why it's a good idea to base things on SIM. If you go back to this model, the location model, what you will notice when you begin looking at it, that actually a lot of the stuff is not SIM. In fact, it's only the blue and the gray stuff here that's SIM. The rest is additions made to the SIM location model. Also, we go down here, we have the route model, which we're going to use to model the entire route network where we put equipment into. I also put that part into the location data model because it's also location-ish, so I put it there. Maybe it's a bad idea to put it in here, but you know, maybe get wiser and then we can always put it in another model. But it was natural for me to put it here right now, so let's see how it goes. I'll try to zoom in a bit so you can read the diagram. Okay, as you probably can imagine, this guy here, the location entity, is of central importance. It works like this, that this guy here is kind of the, you can say, the base entity for all the different types of location entities we have. So if you take, for example, a zone, the zone entity is used to draw some area and kind of divide the net into different kind of zones. And the zone object is also part of SIM. What I have done is I have put an extra enumeration on, which is related to fiber. It's called zone kind. And you can see the enumeration up here. And I put these three types of zone in: the central office zone, flex zones, and customer zone. This is, you know, just an example, and this is the way that many customers divide up the network, at least in Denmark. Maybe some other customers do it differently. And of course, the customer can choose what types of zone they want. So it's just a way to kind of draw some areas and kind of divide the whole network into some areas. This is the zone object. Then we have another guy here, the access address. And in SIM, there's actually no concept called access address. There's something called the street address. Well, this is actually not a good name because we can have access addresses that is not near any street. Think about, for example, stuff that's near a railroad. For example, there could be some cable boxes or whatever, some infrastructure running there, fiber cables, etc. But there's no roads, so street name is, or street address is not really useful. Another example is windmills that stands in the water or in the middle of nowhere. So a better way to model this is to have a concept called an access address. So that's what we have done here. Also, I have made the access address a so-called identified object, which means it has its own life cycle. That's also very important because it's such an important entity, such an important object in the system when doing planning and so forth. Also, another thing I have created is something called a unit address, and what that one does is that it kind of if you have a big building, for example, a condominium or office building, what you will have inside it is a lot of units. And they are of big interest to the fiber planning people too, and also, of course, operation and so forth. So we need to have these two things here as first-class citizens. So that's what we did. And of course, buildings, very important. And also something called building access points. I'll not go into detail about this one. And finally, we have something called road segments, which is the different roads in the system. And then we have some classes down here that can be used or not used if you want to. And this is lists of postal districts and municipal pulse that you can use to look up things. So depending on if this system is going to be the master file addresses, are they coming from another system, you might use these or not. But try to take a look at it and see if well, it makes sense. If not, please tell me. I might have made some errors, but I made this model from a lot of experience with a various system during the last 13 years. And I know that it's very important that everyone agree on this model and everyone kind of know how this works, because it's of vital importance that you have these objects in the system when you have to put all the other objects in. So basically all the network components and so on, they will relate to these objects here, to the location objects of different types. So that's why they are very important. That is kind of the fundamentals. The final thing I'd like to talk a little about is the root network. And it's very simple. We have a root node and a root segment. So a root node is just, kind of a node in the net where something happened. It can be anything from a central office to a junction in the road or customer access point. The root segment is just, a path connecting the two root nodes. I'm gonna switch over to the gear system. It's more easy to see. And you can see here I actually created a little test network, root network. It's wrong to call it a network. It's just, just the root. So if you take, for example, this guy here, now just do the raw data. You can see that it's very simple. It's just geometry, and it has a root segment kind. It's road crossover drilling. So it just means that they have somehow a route that goes from here to here, and it has been drilled. Inside this route there can be a lot of conduits, cables, and so forth. But the only geographical element we're gonna draw an idea is the route. Everything else is related to this guy. Okay. Also, you have the nodes here, and there'll always be a node in the end of a segment, and this node can represent everything from central offices to wells, cabinets, access point into buildings, and so forth. So again, what's inside this black dot is all the related objects that kind of tells what's inside it. Okay. So let's go back. So that's just a very shortly introduction to the root model and the other location entities. And when we begin to look at the equipment model, which contains all the cables and all the fiber equipment in the network, we will see that these will relate to these classes here. So, but things are divided up like this because, again, to kind of, handle complexity, then it's a good idea to divide these things up. I can just show you quickly how it looks in the database. You can see here, if I open the location schema. So we put each type of model into its own schema to kind of divide it up. It's just a logical division of the entities. It doesn't really matter in terms of queries and stuff. You can of course join things together, but it just gives you kind of a kind of encourage people to kind of think of it as different domains or different bounded contexts. So if we take the location domain, you have all the different types of objects here or tables here that all has something to do with, location information. Okay, so that's it. Hope it was useful. But otherwise, you please tell me if something is not clear or doesn't make sense, because this model is really important. It's kind of the basic model we're going to build everything on, you could say. So thanks for watching. Yeah, bye bye.